Welcome to the very first episode of Chemistry on the Fly with Mr. Aff. Today we'll talk about 3.30 nuclide symbols. Now, in order to talk about nuclide symbols, which is new, we have to go through some old stuff. So the first thing we'll talk about is isotope symbols. Now, isotope symbols are good, but they only give us some information about a particular atom. For instance, B11 will tell us, first of all, that it is the element boron with the letter B. It'll tell us that from the periodic table, we'll then know that the atomic number is 5. The number of protons, therefore, is also 5. And the number of neutrons is 6. We'll know that because the isotope's number 11 minus the number of protons is going to be equal to the number of neutrons. Now, that completely forgets about everything else about the atom, which would be the electron cloud and the number of electrons. So, we're going to talk about the nuclide symbol, which gives us a whole bunch more information about atoms. First of all, it'll tell us the element, the atomic number, the number of protons, the number of neutrons, the ionic charge, which is new, and the number of electrons. So let's get started. So this is what the nuclide symbol will look like. You'll notice some of it's a little familiar. First of all, the B in the center will tell us that that is the element. In this case, it will be boron. The 11 in this case will show us that it is the isotope number. That's going to be on the top left corner. Now, on the bottom left corner, we'll then have the atomic number. Then it's going to equal 5 for boron, which it will always be 5 for boron. Now, the new part is going to be the ionic charge. Now, the ionic charge in this case is a +3. That means that we'll have 3 protons more than we'll have electrons. Now, let's go back and talk about each one individually. So first of all, the B will tell us that it is boron, and that is the element itself. Okay, the isotope number is going to tell us that the isotope is B11, which means that the atom's mass is going to be 11 AMUs. Now, what that means is that my number of protons and the number of electrons in the nucleus will equal 11. And remember that the electrons do not have any mass, so they have a net mass of 0. So when we talk about an atom's mass, we're talking about the mass of the nucleus. Again, that's the protons and the neutrons. Okay, the atomic number, as always, will tell us that it is boron. But we also know that the atomic number is equal to the number of protons. And by default, we'll know that the number of neutrons is going to be equal to 6. Now, there's a nice little trick here that if we look at the nuclide symbol, we can take the top number, which is the number of protons and neutrons, or the isotope number, and subtract out the number of protons, and that is going to give us the number of neutrons. In this case, it's going to be 6. Then the last part is the ionic charge. Now, we see that we have a +3 here. That means I'm going to have 3 more protons than electrons. Now, we know from our previous work that the number of electrons is equal to the number of protons minus the ionic charge. So let's see how that works here. So electrons is going to equal 5 protons minus a +3, which is my charge, which means that this isotope of boron is going to have only 2 electrons. Well, right now I'm showing, well, not anymore. That's 1 down, 2 down, 3 down. So now 2 electrons. Now this is what a particular atom of boron will look like when it is when it has a charge, or it is an ion. In this case, it would be a cation. And you can see that the electrons are in the electron cloud somewhere, and the nucleus is pretty stable in the center. Now, what happens when we go back to having 5 electrons like I showed before? In this case, we have the electrons is equal to the number of protons minus the ionic charge. Now we can flip this around and then solve for the ionic charge, which means it's going to be the number of protons minus the number of electrons. So let's put our numbers in. So ionic charge is equal to the protons minus the number of electrons. In this case, it's going to be 5 minus 5. Remember, I have 5 protons because it's boron, and I also have 5 electrons. And then if you subtract the 2, you get 0. So then I should put a 0 on the top here. Now that would be nice, but we find the chemists are pretty lazy. So what happens is they do not put a 0 there at all. They leave it blank. So what we can see is a blank ionic charge means that the atom is neutral. And in turn, that means I have the same number of protons as electrons. Now, that's about all I've got for the nuclide symbol, but let's do a little review. So the nuclide symbol tells us the element, the atomic number, the number of protons, the number of neutrons, the ionic charge, and eventually the number of electrons. That's the last page of Chemistry on the Fly for today. Come back again. This is Mr. F, and as always, have a great day. Now, as you can see, I have